In this video, we're going to take a look at the practice questions for even and odd functions and trig function transformations. So looking at question 1, below is the graph of f of x equals sine x. Is this function even, odd, or neither? So they give us this graph we're going to utilize, and we have to make this determination if it's even, odd, or neither. So when I look at this graph, there's a couple of questions I have to make. If you remember from observation, if the function is even, we are symmetric about the y-axis. If I fold this graph in half across the y-axis, is it the same on both sides? And if you imagine doing that here on the y-axis, folding, it's not going to be the same, is it? Because you'll have this part of the graph over here, and this down there, that's a different graph. They're not symmetric about the y-axis. Now to determine if the function is odd, we are symmetric about the origin. Remember I said to remember the O in origin with odd. That will help us. So we do the 180 test on this. When we rotate this graph 180 degrees, does the graph look the same? And if it does, that means it is symmetric about the origin. And that is the case here. If you can imagine rotating the graph 180 degrees about the origin, it is the same, and that means this function is odd. That is answer choice B. Question 2 says the graph of the trigonometric function y equals 3 cosine 2x is shown below. The function is, and when we look at our answer choices, we see that they're asking for a couple of different things about even or odd, neither even or odd, undefined at a certain point, or the inverse of the cosecant function. Well, one thing that might get some people is when we are given this function itself, this y equal value, we may get a little confused and think, well, I'm not sure what that is. But the great thing is here, they give us a graph. We can answer this by observation. The first thing to me that's the easiest to look at is to see if we're talking about being even, odd, or neither even and odd. And if you really look at these choices, you know that any graph is going to be one of these three. So it means one of these three has to be correct, and that would mean you don't even have to worry about J or K. So looking at even and odd, what we talked about before, starting with even. Now they give us the definition here that gives us these values of when we plug in negative x and what we find. We could do that with this function right here, but to me it's so much easier to look at this graphically. So thinking of even, we want to determine, is the graph symmetric about the y-axis? Thinking about folding this on top of the other, do we still have a symmetric graph? And we do. So that means this graph is even, it is symmetric about the y-axis, and that's answer choice F. Now let's look at number 3. A function f is an odd function if and only if f of negative x equals negative f of x, and that is the definition of odd, for all x in the domain of f. Which function graph below is not, I want to make sure I see that word, not an odd function. Now again, we're given a graphical representation, so I'm not going to necessarily worry about this definition. You could, but I like to do the test, are we symmetric about the origin? And what that means, the 180 test. So that's what we want to look at. When I rotate, we'll just start with graph A. When I rotate this graph 180, do I have the same graph? And if you can imagine rotating this, this is going to come down to here, that's going to go up to there, and we do have the same graph. So this one is odd. Let's look at number B. Again, we'll do the 180. And this should remind you of the question above in number 1 of our sine graph. And when we rotate this 180, yes, we still have the same graph. What about this one? This was our choice in number 2 above. And if we rotate this 180, this portion becomes low and that's high. That's a different graph, isn't it? And we already knew in number 2 that it is even. A cosine graph is even. So this one is even. This is actually going to be our answer. Answer choice C is not odd. But let's just look at the others just so we can visualize this. We do the 180 test, 180 of that line, that goes there, this one goes here. Same graph, symmetric about the origin. And that's because also that it crosses here, it goes through the origin. If we had had a line up here, that would not have been symmetric about the origin, okay? But in our case, we could stop with answer choice C. We wouldn't have even been given that if as long as we had C. Looking at E though, just to confirm to ourselves, when we move this one, when we rotate 180, we'll be down there. This portion will be up here, and then we have our same graph. So we are symmetric about the origin. So our choice again, answer choice C is correct. Question number 4, we're going to make a shift to our trig function transformations now. What could be the equation for a cosine graph with a period of 4 pi, an amplitude of 2, and a horizontal shift of 2 units to the right? So we've got some good information here that can help us in figuring out which one of these equations represents these transformations. What I always like to start with, to me that's the easiest, is an amplitude of 2. And remember our form of the equation is going to be our amplitude, and we have our amplitude times the cosine of bx minus c plus d. Okay, we have any kind of vertical shift, and we don't mention that in any of our wording here, so we're actually not going to have that. Our horizontal shift is going to come into play with what's inside the parentheses. And as we can look at our answer choice, that we see that we don't have any values out in front. But our amplitude 2, each one of these has an amplitude of 2, so we can't eliminate anything on that. So what's going to make the difference is this period of 4 pi and a horizontal shift of 2 units to the right. Okay, remember our period is equal to 2 pi over b. And we are given that our period is equal to 4 pi. We're given that in the equation. So we can find what b is equal to. We want to solve for b, and b is going to be equal to 2 pi divided by 4 pi, which gives us 1/2. So b is going to be 1/2. So we already know we're going to plug in 2 for a. We have cosine. B we just found to be 1/2 x. And if we look at our choices, we can do some eliminating. F, J, and K are out. We're down to the 2 choices of G and H. Is this going to be a -1 or a +1? All right, for our horizontal shift, we get that from C over B. We just found B to be 1/2. We can put that there. And we know that our horizontal shift is 2 units to the right. So let's solve for C. We're going to multiply both sides by 1/2, and we get C is equal to 1, and that means we're going to plug it in straight into our equation, which already has a minus sign in it. So we'll plug in the value of 1 for C, and we get this equation 2 cosine of 1/2 x minus 1, which is answer choice G. You just work each piece at a time until you can find that equation that is represented there. Now taking a look at question 5, the graph of y equals sine x in the standard xy coordinate plane is reflected over the x-axis, shifted down a units, and then shifted right pi units. Which of the following equations represents the graph after the 3 transformations? So our basic equation for a sine function is y equals a sine of bx minus c plus d. Let's see what we've got here in our transformations. The first one is that it's reflected over the x-axis. So that's going to mean we're going to have a negative sign out in front. And that is what goes out in front. We don't have anything about a change in amplitude, so we assume that to be the 1, but we do have a negative in front of our sign. So we know we can write that thus far. So each of these cases, we look at our answer choices, we have negative in 4 of those. We can eliminate C because they use a positive right there. The next thing we want to look at, shifted down a units. that is a vertical shift down a units. So that's going to be represented here with this D. So we're going down a units. Our sign matches here, whatever direction we're going. So in this case, it looks like we've written it backwards from our standard form, and that's fine. But we know we were going to go negative A, so that only leaves, the only place that we have the negative A is answer choice A. So that's going to be our answer. We could stop at that point, but I'm going to go ahead and show you about the shift right pi units. So remember, that has to do with our C value. So we have no change in that talks about in terms of our period. So we will just have a 1x in front of that. And remember, we talked about the shift being C over B, and in this case, B is equal to 1, and it's going right pi units. That shift is pi. So that changes our C. We can find C over 1 to be equal to pi. So in this case, C is just equal to pi. Remember, the negative sign is part of the standard equation. So when we plug in the positive pi, it comes into be x minus pi, and that all matches up with our answer choice A. Looking at number 6, the functions y equals cosine x and y equals cosine of x plus a plus b for constants a and b are graphed in the standard xy coordinate plane below. The functions have the same amplitude. One of the following statements about the values of a and b is true. Which statement is it? So when we look at just y equals cosine x, when we look at our graph, we want to be familiar with what this basic y equals cosine x looks like. And that is the one that we have in blue. And we can tell that because we know the basic structure. It goes up to the point 1 and down to negative 1 in the cycle of the graph. So that leaves y equals cosine of x plus a plus b to be the yellow graph. So when we're looking at our different answer choices, we're wanting to see how a and b, what our values might be. So if we look at everything, it tells us already that the a values are the same. We have amplitude of 1 for each case. We can see that where we were using 0 as our halfway point between our graph, it looks like now for this y value, the halfway point occurs at 1. So it looks like the entire graph, every point shifted up 1 unit. And so that's where we have a case right here with B. B is going to be, in this case, it's actually equal to 1. We can determine that from our graph. And that, from the cases that we have, it's either, is it equal to 0? It's not equal to 0. So we're going to eliminate F based on this B value. We know B is equal to 1, so it's going to be greater than 0. So we can eliminate H and J because they say B is a negative number, but we're shifting up. Now, the distinguishing factor between G and K is A equal to 0 or is A greater than 0? Is it a positive number? And remember, our A value has to do with a horizontal shift, left or right. When we look at our graph, everything lines up horizontally. They are the same. So it doesn't appear that there's any shift here, and that would make us have an A value of 0. No horizontal shift, only a vertical shift upward. That's answer choice G.